are you? I hope you're keeping well. Welcome to another lesson on air and combustion. Now, when we talk about air, we are talking about everything that is surrounding us in the space, in our space. And sometimes it constitutes the oxygen we breathe, carbon dioxide, which is taken by plants during photosynthesis. It also talks about the dust particles that are present in the air. It also involves smoke, some smoke particles, especially in places where there is burning. And also, what else? There is nitrogen in air. There are the rare gases also present in air. In places like in the coastal regions, there is the water vapor, the humidity. So all these are found in air. But we want to specifically look at the types of gases that are present in air and their names. So welcome as we look at this very interesting topic of air and combustion. Now, from there we can be able to define air as a mixture of gases which occurs in some percentages as shown in the pie chart given below. Now let us have a look at this pie chart. You realize that 78% of air is nitrogen. Therefore, nitrogen, which is the inactive part of air, forms about 78% by volume of air. Then it is followed by oxygen, which covers about 21% or 20.9%. Then we also have argon, which represents the inert gases at 0.9%. Other gases are also present, composed of maybe even dust particles and the like at about 0.17%. And then we have carbon dioxide, which is also having a percentage of about 0.03%. Now, these values may vary from one reference to another. Therefore, some books will talk about oxygen having a 21% and some little variation here and there. But these are just estimates of the amount of air, a specific gas in air, a specific gas present in air. Now, we have some experiments which help to determine the percentage of the active part of air. Now, this active part of air is that part which supports combustion, and its percentage, as we've seen on the pie chart, is about 21%. And there are experiments that can be used to be able to come up with this estimate. We perform an experiment and try to prove whether, for sure, the active part of air, which is oxygen, is about 21% by volume of air. Now, these experiments include using a burning candle. We can be able to use a burning candle to find the percentage of air by volume. We can use the phosphorus, smoldering of phosphorus, to be able to find out the percentage composition of oxygen in the air. We can also use burning of copper metal in air to be able to find whether that percentage is actually 21%. And we also have rusting of iron filings. Now, these experiments are possible because normally the reaction taking place is consuming that part of air which is active, and that is oxygen gas. So, by consuming the oxygen gas that is present in the air during the reaction, then we can be able to estimate the percentage of oxygen by volume in the air. Let's start with the first experiment, finding the composition of air that supports combustion using a candlestick. Now, this is the procedure for this reaction. Place a candlestick on a bottle top, float it on sodium hydroxide solution in a trough, cover it with a gas jar, mark the level of the air in the gas jar. Of course, the gas jar will enclose some air, so we mark the initial volume of air on the gas jar. That will be the point where the water reaches after covering the candle with the gas jar. Then after making that mark, then we remove the gas jar and light the candlestick. Then we carefully cover it with the gas jar. Now, observe what happens for 2 minutes. And then mark the new level of the air in the gas jar as the final volume. Observations and explanations. Now you will realize that the level of solution rises in the gas jar so as to occupy the space left by the used up oxygen. How was the oxygen used up? During combustion. We know that oxygen is the part of air that supports combustion. Therefore, it was used up, and therefore a vacuum was created. And because nature does not allow vacuums, the solution had to rise up to cover that empty space, and that's why the level of the solution was noted to go up. Now, we can be able to calculate the percentage of air which is used up during this reaction by taking the initial volume of air minus the final volume of air over the initial volume of air times 100%. So that one is going to give us the percentage by volume of air that was used up during combustion. Now, the following are sample results from a similar experiment whereby the initial volume of air in the gas was 90 centimeters cubed and the final volume of air in the gas jar was 75 centimeters cubed. This is now how we calculate the percentage amount of air used during combustion. So we shall say 90 minus 75 over 90. Then whatever you get, you multiply by 100. Now, if you check from your calculator, you realize that it is going to be about 16.67%. Now, this is a value which is lower than the value we expect from the theory we have already discussed, that the percentage of oxygen by volume in air is 21%. Therefore, we need to look for the causes of the value going down to 16.7%. But before that, let us first of all see what happens with the candle wax burns in oxygen. Now, when candle wax is burned in oxygen, since it is an hydrocarbon, it burns to form carbon dioxide gas and water. So candle wax plus oxygen gives us carbon dioxide gas plus water. Now let us now look at what would have caused the volume of oxygen to go down to 16.67 in this experiment. Now, during an experiment, there are some errors which may be committed and which may affect the theoretical value of the oxygen we expected to find from our experiment. One of those errors is candle may go off before all the oxygen is used up due to the buildup of carbon dioxide gas. Yes, the moment you trap, you invert the gas jar on top of the candle, you trap just a little air inside. That air should have oxygen, nitrogen, and all other parts of air present in it. Therefore, what happens is that the candle can go off before all of the oxygen is used, because when heating, carbon dioxide gas is emitted, and therefore it would accumulate within that gas jar, such that the candle may go off even before all the oxygen has been consumed during the burning of the candle. Now, the other error would be the sodium hydroxide may not absorb all the carbon dioxide produced. Remember, we used sodium hydroxide because its function is to absorb carbon dioxide. So, maybe it did not absorb all of it. That will lead to accumulation of carbon dioxide gas, which will definitely lead to the candle going off before all the oxygen in the gas jar is used up. So those are some of the errors that may have led to producing a lesser value than the theoretical value. Now, some points to note. During this experiment, we have some important points which we need to note. One of them is that dilute sodium hydroxide is preferably used instead of water, because carbon dioxide is slightly soluble in water but very soluble in sodium hydroxide. Therefore, it absorbs most of the carbon dioxide gas. Now, another point is that the apparatus should be allowed to cool before final reading is taken, because the heat causes expansion of gases, and this may lead to taking up the wrong value. So, it is important that after the candle has gone off, we don't take the reading immediately, but let the setup cool down. Then we can take our reading to avoid taking a false reading. Now, let's look at these questions. Name 2 non-poisonous gases produced by a burning candle. So here we have carbon dioxide gas is produced by a burning candle, and also water vapor. It's also a non-poisonous gas. So those 2 gases are non-poisonous gases which are produced by a burning candle. Name 3 substances other than oxygen and nitrogen that are always present in the atmosphere. Question number 3. Below is an experiment set up to determine the percentage of oxygen in air. Use the setup to answer the questions that follow. So in that setup, you have a candle which is lit. In the second diagram, a gas jar is placed over the burning candle. And in the last setup, we have the candle going off and the level of sodium hydroxide raising, and we have been given the levels in terms of centimeters. So the questions are: describe what happens when the burning candle is covered with a gas jar. Question number Roman 2. Explain why sodium hydroxide solution rises in the gas jar. Question Roman 3. Explain why sodium hydroxide is used instead of water. And Roman 4. Calculate the percentage of oxygen in air used using the results of the experiment. So try and answer the questions I've just given. They are for practice and they are related to what we've covered in this subtopic. Then remember to comment, subscribe, and follow Teacher Mercy for more interesting lessons in future. Thank you.